Friday? Not next month, not sometime soon. This Friday. Across California, emergency management teams are reviewing protocols. Seismic monitoring stations are being watched a little more closely. Analysts are staring at screens filled with subtle, restless data. Lines that look calm to the untrained eye, but aren't. And almost no one outside the scientific community realizes why this specific day matters. At the same time, nearly 6,000 miles away, the ground in Sicily hasn't stopped moving. Not dramatically, not in a Hollywood way, but steadily, persistently, measurably. Two regions, two tectonic front lines, and experts are watching both. Because sometimes it's not the massive quake that raises alarms. It's the quiet build-up before it. California sits on a boundary the entire world knows by name, the San Andreas Fault. A fracture stretching roughly 800 miles, slicing through deserts, mountains, and cities, a slow-motion collision between the Pacific Plate and the North American Plate. These plates don't glide peacefully. They grind, they lock, they build pressure over decades, and then sometimes they release it all at once. But here's what makes this week different. Over the past several days, clusters of small tremors have been detected in specific segments of California's fault system. Not catastrophic, not headline-grabbing, but patterned. Seismologists refer to them as swarms, a series of minor quakes in tight geographic proximity. Usually, swarms dissipate quietly. Usually, but that's not the most concerning part. Data suggests subtle ground deformation in certain monitored areas, the kind measured in millimeters, shifts so small you'd never feel them under your feet, yet instruments can. And instruments don't guess, they record. Friday matters because a scheduled stress model recalibration is aligning with atmospheric pressure fluctuations and tidal gravitational peaks. These factors alone don't cause earthquakes, but they can slightly influence already stressed fault lines. Early signals indicate elevated microseismic activity in parts of Southern California. Not panic-worthy, but not nothing. Residents in communities near the Salton Sea have reported feeling light, rolling tremors, the kind that make you pause mid-sentence and glance at a hanging lamp. Then it stops. Life continues. But beneath the surface, friction accumulates. California has lived with this tension before. In 1989, the Loma Prieta earthquake struck during the World Series. In 1994, the Northridge quake caused billions in damage and changed building codes forever. Each event followed years of stress buildup that most people never noticed. That's the pattern experts are trained to recognize. And right now, some of them are leaning forward, but let's be clear. No one can predict the exact day of a major earthquake. Not Friday, not next week, but officials can assess risk windows, periods when multiple variables overlap. This Friday, several overlapping data points converge, and almost no one is talking about it. Seismic risk assessment isn't dramatic, it's math, it's probability curves, it's decades of geological history layered over current readings. One researcher described it as watching a stretched rubber band. It might snap, it might not. But you measure the tension, and when tension rises, you pay attention. Here's what makes it psychologically unsettling. Earthquakes don't give visible warnings, no dark clouds, no sirens from the sky, just stillness, then motion. California's early warning system, Shake Alert, has been tested repeatedly over the past year. Notifications can reach phones seconds before shaking arrives. Seconds. That's how thin the margin is. Emergency planners review response times. Hospitals review surge capacity. Utility companies run scenario simulations, and yet daily life feels completely normal. Traffic on the 405. Surfers in Malibu, students walking across campuses built atop shifting earth. Because most days, nothing happens. Until it does. Now let's widen the lens. Across the Atlantic in Sicily, the ground has been behaving differently. Near Mount Etna, Europe's most active volcano, instruments have recorded ongoing ground uplift. Slow inflation beneath the surface, the kind that suggests magma movement or tectonic stress adjustment. But that's not the most concerning part. It's not just volcanic. Geodetic measurements show sections of eastern Sicily gradually sliding toward the Ionian Sea. Not collapsing, sliding, millimeter by millimeter per year. That movement has been known for years, but recently the rate has fluctuated, subtly. enough to prompt intensified monitoring. Sicily sits at a complex junction of tectonic forces, the African plate pushing northward beneath the Eurasian plate. It's a region shaped by deep geological tension. Historically, that tension has released catastrophically. In 1908, a devastating earthquake struck the Messina region, killing tens of thousands. It remains one of Europe's deadliest seismic disasters. That memory lives in the region's architecture and in its caution. Today, residents in Catania report occasional tremors, minor cracks in older buildings, the quiet awareness that Etna is always there, always breathing, and scientists are watching deformation maps that update in near real time. So what connects California and Sicily? Not directly. There's no secret seismic trigger linking them across oceans, but both sit on active plate boundaries. Both are experiencing measurable ground changes within short time frames. And globally, tectonic activity follows cycles, not synchronized, like clockwork, but influenced by broader stress redistribution patterns across plates. When one region releases stress, neighboring segments sometimes adjust. It's not dominoes, it's more like a complex web of tension. The Earth's crust is fractured into enormous slabs constantly interacting. Most of that movement is invisible to us, until it isn't. And here's where it becomes psychologically gripping. We live in an era of hyper-awareness. Data from satellites, GPS stations, ocean buoys, everything feeds into global monitoring systems. We know more than any generation before us about the Earth's internal mechanics. Yet uncertainty remains. California officials emphasize preparedness, not prediction. Sicilian authorities focus on monitoring, not alarm. Experts are closely monitoring seismic swarms in Southern California and ground deformation around Mount Etna. Data suggests elevated but not extreme activity levels. Early signals indicate increased strain accumulation in specific zones. Notice the language: careful, measured. Because science doesn't dramatize, but patterns matter. Here's a pattern few people consider. Over the past decade, several significant global quakes occurred after periods of increased microseismic clustering. Not always, but often enough to be studied. Microquakes can relieve pressure, or they can precede larger ruptures. That ambiguity is the tension. Imagine living above a fault line knowing pressure is building, but not knowing whether small tremors are releasing it or foreshadowing something larger. That's California. Now imagine watching a volcano inflate gradually while coastal land subtly shifts seaward. That's Sicily. And then something shifted. In California, a midweek swarm recorded slightly deeper hypocenters than earlier in the month. Not drastically deeper, but deeper. Depth can influence rupture behavior. In Sicily, satellite interferometry showed a marginal acceleration in a known sliding zone along the eastern flank. Not dramatic, but measurable. Officials didn't expect that rate change so soon. Again, not a crisis, but not routine either. Residents respond differently. In California, preparedness kits are dusted off. Social media threads debate the big one. Some dismiss it entirely. In Sicily, local fishermen shrug. They've lived with Etna's rumble for generations. Others quietly check evacuation routes. Humans adapt to risk until risk adapts back. That's the psychological paradox. When tension is constant, it becomes background noise, until it becomes foreground reality. Consider the Northridge earthquake again. Many residents recall it as an ordinary January night. No unusual signs, no warning sirens, just 4:31 a.m. and violent shaking. Now consider the 1908 Messina quake. It struck at dawn. Entire districts collapsed before people fully understood what was happening. History doesn't repeat exactly, but it rhymes in stress cycles. Experts emphasize there is no confirmed imminent disaster for this Friday. Let that be clear. But Friday represents a convergence of monitoring thresholds and model updates that scientists are evaluating closely. Think of it like a medical checkup when certain readings are slightly elevated. You don't declare an emergency. You monitor more closely, and you prepare. Because preparedness is rational, not fearful. California's infrastructure has improved significantly since the 1990s. Retrofitted bridges, stricter building codes, public alert systems. Sicily has invested in volcanic surveillance networks and structural reinforcement. Yet, vulnerability remains, dense populations, aging buildings, critical supply chains. If a moderate quake struck Southern California, millions would feel it within seconds. If significant movement occurred along Etna's flank, transportation routes could be disrupted. But here's the quiet detail few headlines mention. Global seismic activity fluctuates seasonally and cyclically. Some researchers explore correlations with tidal forces, atmospheric pressure shifts, and even long-term climate interactions affecting crustal loading. The science is evolving, and almost no one is talking about how interconnected our monitoring systems have become. In Pasadena, researchers analyzed tremor waveforms in real time. In Catania, volcanologists examined deformation graphs from satellites orbiting hundreds of miles above Earth. Two teams separated by oceans, both staring at the planet's subtle movements, both aware of history, both aware of uncertainty. The Earth doesn't operate on human schedules, but human attention does, and this Friday has captured attention within certain scientific circles. Why? Because overlapping stress indicators, minor but layered, create what analysts call a watch window, not a prediction. A watch. It's the difference between storm forecasting and storm certainty. You track pressure systems, wind shear, ocean temperatures. Sometimes storms dissipate, sometimes they intensify. The same principle applies beneath our feet. Now imagine standing in downtown Los Angeles at sunset. Skyscrapers glowing, traffic humming, nothing feels unstable. But dozens of sensors buried deep underground are transmitting constant data. In Sicily, tourists photograph Mount Etna against a Mediterranean sky, unaware that beneath that beauty, magma chambers pulse slowly. This isn't a story of panic, it's a story of awareness, because the unsettling truth is this: we cannot stop tectonic motion, we can only prepare for its consequences, and preparation begins with attention. Then something else happened, a slight uptick in harmonic tremor signals near Etna, vibrations often associated with magma movement. Simultaneously, California's Caltech monitoring systems flagged minor stress transfer along a connected fault branch. Individually, these signals are routine. Together, they raise eyebrows, not alarms. Eyebrows, experts are closely monitoring. That phrase matters. Monitoring means watching trends over time. Looking for acceleration, looking for correlation, looking for deviation from baseline behavior. Baseline is comfort, deviation is curiosity, and curiosity is where science lives. Residents in San Bernardino County recently attended earthquake preparedness workshops at higher attendance rates than earlier this year. In eastern Sicily, civil protection authorities quietly reviewed contingency plans for landslide scenarios near coastal villages. No press conferences, just preparation. Because seasoned officials know the cost of underestimating subtle signals. The earth rarely shouts first, it whispers. And this week, in two separate corners of the world, those whispers are being analyzed. Let's pause for perspective. On average, the planet experiences thousands of small quakes every day. Most are too small to feel. Tectonic plates are always moving, roughly as fast as your fingernails grow. Constant, unstoppable. What makes this moment different is not the existence of movement, it's the clustering of attention around specific indicators. California's long-anticipated big one is statistically inevitable at some point in the coming decades. Sicily's volcanic and tectonic activity is historically cyclical. The question is never if movement will occur again. It's when and how strong. Friday is not destiny, but it is a focal point for updated stress modeling and data review. If nothing significant happens, that's good news. If minor tremors continue, that's still within expectation. But if patterns shift suddenly, if micro-quakes escalate or deformation accelerates, response protocols activate quickly. Seconds matter, minutes matter, communication networks matter, and human behavior matters most. Because fear spreads faster than seismic waves. That's why credibility matters here. There is no confirmed catastrophic forecast, no secret prediction hidden from the public, only data trends and heightened vigilance. As we approach Friday, researchers in California and Sicily will do what they always do: analyze waveforms, compare historical baselines, refine probability models. Most likely, life will continue uninterrupted. But uncertainty remains, and uncertainty is uncomfortable, yet it's also honest. The Earth is dynamic. Living atop tectonic boundaries means accepting that stillness is temporary. So what should viewers take from this? Not panic, not dismissal, but awareness. Check emergency kits. Understand local evacuation routes. Know how to respond when shaking begins. Because preparation is empowerment. And here's the final unsettling truth. When major geological events occur, they often feel sudden. But they are rarely random. They are the culmination of years, sometimes centuries, of accumulating stress. Stress we can now measure. Stress we are measuring this week. California is on alert. Sicily's ground is still moving, and the world keeps turning. Friday may pass quietly, or it may deliver another reminder that beneath our cities, forces older than civilization continue their slow, relentless motion. If you live in a seismic zone, what does preparedness mean to you? Have you felt tremors recently? Share your experience, because collective awareness strengthens communities. The earth does not pause. It does not negotiate. It shifts. And sometimes, when we least expect it, it reminds us who truly holds the ground beneath our feet.